Hello, my name is Tony Rodriguez and I'm a PhD student here at Caltech. Today I'll be presenting my latest paper, which involves a discovery tool that spans everything from active stars, as the ones you see on the left, to stellar mass black holes, like you see on the right. I'll be talking about how ZTF data in particular has allowed for the discovery of new systems in conjunction with this tool. So ZTF, the Zwicky Transient Facility, is a 1.5 meter telescope in Southern California. And the reason that it's so powerful is because it's robotic and can scan the entire sky very quickly. What that gives us is something known as a light curve, which is the brightness of an object as a function of time. And with this light curve generated by ZTF spanning 6 years, you can see that this particular object undergoes these dips, it undergoes outbursts, and there's really a lot of rich things to understand just based on this alone. However, because ZTF really spans the entire northern sky, it generates not just a lot of light curves, but also light curves that have thousands of these points per light curve. And looking at the raw numbers, there's over 1 billion sources that ZTF has generated high quality light curves for. So how do we tackle this? How do we actually make discoveries through such a rich data set? And for my work and for the work of a lot of people in the astronomical community, the answer is to go into X-rays and to use X-rays to supplement the visible data like the one that ZTF generates. So if you look at a patch of sky, just in visible or optical light, like you see on the right here, there's about 50 sources there. However, if you go to the X-rays, like you see on the left, there's only going to be one source, and that's going to be the source of interest. That's going to be the interesting one. So there's no need to try to go through the ZTF light curves of the 49 other sources. X-rays allow us to basically just focus on one. So with that in mind, the X-ray main sequence comes to the rescue. So the X-ray main sequence is the name of this diagram that I've created and that I'm presenting in this paper, and it allows for the discovery of a very rich variety of astronomical objects. You can discover cataclysmic variables like the ones here on the left, colored in red here on the X-ray main sequence. These systems are systems that are binary star systems where a white dwarf basically is accreting mass from a donor star. White dwarfs are stars that have the mass of the sun, but squeezed into the size of Earth. You can also find black widow pulsar systems. These are also binary stars, but instead where you have a neutron star known as a pulsar. These systems are also about the mass of the sun, but compressed in the size of a city, so even more extreme than white dwarfs. You can also see here black hole X-ray binaries in the diagram in blue. So these are systems where there's either a neutron star or a stellar mass black hole next to a close companion. There are also other sorts of objects revealed in this diagram, such as a population of young stellar objects. These are the environments where stars and planets form, as you can see here on the left. And then in green are active stars. These are magnetically active stars. So you're seeing here a picture of basically the active sun, and those loops are caused by magnetic activity on the sun. And a lot of the systems here are basically more extreme analogs of that. And then finally here you can see systems known as symbiotic stars, where it's also a white dwarf next to a close companion, but the close companion here is actually a red giant, so a star that's about hundreds of times the radius of the sun. To sum it all up, basically these 3 types of objects can be placed on this diagram and into these general categories and cleanly separated. And just to show how ZTF can enable the discovery of new types of systems, because cataclysmic variables are binary stars and revolve around one another, you should see periodic variability that repeats itself in their light curves. So first, I picked a set of candidate cataclysmic variables, as you can see on the left there. And then I obtained their ZTF light curves, and indeed you can see that there's periodic variability. But really the gold standard to confirm everything is through optical spectroscopy. So indeed, these spectra reveal that these are various flavors of cataclysmic variables. So just to sum up, ZTF data is very extensive, and it's almost too extensive to mine on its own. And upcoming surveys like the Rubin LSST are on the horizon, which will generate 30 to 40 times more data. The X-ray main sequence is a simple tool to basically combine X-ray and optical data and make discoveries tractable. And thanks to ZTF, we can sort of confirm these discoveries and actually put the tool to use. So because there are so many upcoming X-ray and optical surveys, this is really just the iceberg. Thank you.